Let's look at JAMB Physics 2022 question 21 to 30. Question 21 says, for correcting long sight defects in the human eye, we require A. Converging lens, B. Diverging lens, C. Microscope, D. Periscope. Now you need to note that when they say long sight defects in person causes the person to see far or objects that are far but cannot see near objects. It is corrected with the aid of a converging lens in front of the eyes. So for this, the answer there is A, converging lens. Now this is under optics 21. 22, when two mirrors are placed at an angle of 90 degrees, so there should be a degrees here, angle of 90 degrees to each other, how many images will be formed when an object is placed in front of the mirror? So how do we solve this question? The option there, A, 5, B, 4, C, 3, D, 2. Now to solve this question here, you need to know the formula. This is for question number 22. For 22, you need to know the formula that the number of images formed, n, is given by the formula, or it's equal to 360 all over the angle minus 1, right? So that's a formula. Now with this, let's impute the values. They said when the angle, at an angle of 90 degrees, so that means theta is equal to 90. We'll have the n is equal to 360 all over theta is 90 minus 1. This is equal to, if you cancel this, all right, 36 over 9, you have 4. That becomes 4 minus 1. And from here, n is equal to 3. All right, so basically, remember this formula that the number of images formed would be equal to 360 all over the angle minus 1. So with this formula, our answer gives us n is equal to 3. So for this question here, the answer is 3. That's the answer. Next up, question 23. It is known that a neutron exists in a light atomic nucleus. Which of the following also exists in the nucleus? All right. You have A, an electron, B, a beta particle, C, beta particle, D, proton. I think B should have been alpha beta particle, perhaps. Anyways, D, proton. So what's the answer to this question? We'll talk about nucleus of an atom, right? You have this, right? You have this. Then you have electrons. You have something like this, where you have electrons revolving around the nucleus of a cell, and you have electrons this revolving around the nucleus of a cell in orbit, right? For an atom here, what you have here is the electron. So the electron revolves around the nucleus of a cell. Now inside the nucleus of a cell, which is this middle part here, let me bring this out here, this one here. Inside the nucleus of a cell, you have two things there. Number one, you have neutron. Number two, you have proton. So considering our option there, you can say that there's no neutron, but they mention proton. So in essence, for this question there, the answer is proton. But you want to know that the nucleus, the atomic nucleus, contains both proton and neutron. But since neutron is not here, we'll take just proton. So the answer there is proton. That's the correct option. Question 24 says, a string of length 5 cm is extended by 0.04 meters when a load of 0.8 kilogram is suspended at the end. How far will it extend if a force of 16 Newton is applied? You're asked to take G as equal to 10 meter per second squared. Now, if you're asked to find how far will it extend, what they're asking you for here is extension. They mention force, they mention extension. The question now becomes, which formula try to relate force and extension? And the answer there is Hooke's law. So this is question 24. From 24 there, question 24, remember that from Hooke's law, this is under elasticity. From Hooke's law, you have that F is equal to KE from Hooke's law. Now, coming back to the question there, let's pick out values. They said a string of length 5 cm. So you're giving length L. it's equal to 5 cm. Perhaps we need to convert. Next, they said is extended by 0.04 meter. So extension E, it's equal to 0.04 in meters. Okay. When a load of 0.8 kilogram, so load, let's call the load force. So load or force are used interchangeably. 0. Let's say this again, 0.8 kilogram. But then you want to observe that this load is given in kilogram. In essence, what I have there is not a load but mass. So mass is equal to 0.8 in kilogram. Moving on, they said is suspended at the end. How far will it extend if a force of 16 Newton? Now, they give you a second condition here. They said force F is equal to 16 Newton. You're asked how far will it extend? Let's call this extension 2. Now, when you have this, the question would be, if I already have extension here, why do I now have, or why am I now asked to find another extension? That becomes the question. And if you want to look at this question here, observe that they said when a load of 0.8 kilogram here, this load here still represents a force. So all we have to do in this question, the first thing we want to do here is to, from here, you can see that in this first part here, what you're given here, you have the value for extension. Technically, you have the value for force because we can get force by saying force is equal to what there? Mass times gravity. You now see why you are given the value of gravity here, right? So let's get the force in this first part there. That means from here, force is equal to mass 0.8 times gravity, which you're asked to use 10, not 9.8. We're asked to use 10. So F is equal to 0.8 times 10 gives you 8 Newton. Now, in the first case, observe that I have the value for force and also extension. Let's get the K, the value of K, which is the constant. All right. Let's get the constant there. So we have that, recall, if F is equal to KE, to get the value of K, I'll divide here by E, divide here by E. This cancels this. So the constant there, K, is equal to F over E, which is 8 all over E, 0.04. That's this. So I have this as 8 all over 0.04, and that's equal to, so I'll get my calculator and try to punch this. 8 divided by 0.04, that gives about 200. That's 200 unit. Force is in Newton, all over extension is in meters. Look at this. So I'm having Newton per meter. And this constant remains the same, irrespective of a change in force. That means from here, now this is for, now the constant remains the same, irrespective of the change in force and extension. Now for the second case, I was given a second force. They said the force was now increased to what there? 16 Newton. And I'm asked to find the extension. How do you find the extension? From here, we'll have that F2 is equal to K times E2. Observe that I just use K. I didn't use K2 because K is a constant. From here, we can have that to get the value of E2, I'll just divide here by K and divide here by K. This cancels this. So the extension we are asked to find is equal to the value of F2, which is 16. So that's 16 all over K. The value of K here is 200. The value of K here is 200. So 16 over 200. Let's get this done. So 16 divided by 200. And if I punch that correctly, my answer is 0.08. 0.08. The extension here is in meters. So my answer is 0.08 meters. I'll check which option has that. But before then, you want to observe that the value of L was given 5 meters or 5 centimeters, but we did not use it. All right. So you want to take note that we did not use it. We did not even need to use it. So take note. All right, let's see 0.08 meters. That's option D. That's the correct answer. 0.08 meters. All right. Okay, next up, question number 25. Question 25 says, what is the speed of a body vibrating at 50 cyclic, it should be cycle, 50 cycle per second, all right? What is the speed of a body vibrating at 50 cycle per second, all right? How do we solve this question? What do we do? Now, here's what to note. To solve this question, you need to note something. And note that when you say 50 cycle per second, note that one cycle, all right, one circle is 1 circle per second is equal to 2 pi rad per second. Okay, now having this, with this particular relationship, you can now solve this question. So if 1 circle is 2 pi rad, they're now asking you 50 circle. 50 circle, 50 circle per second will be equal to unknown. All right. But before you solve this question, don't forget this particular relation. This is what you need. That 1 circle is 2 pi rad per second. And the simple reason is because when we say 1 circle is 360 degrees. All right. If I go through 1 circle like this one here, the total angle there is what? 360 degrees. And we also know that the value of pi, when it comes to angular measurement, pi is equal to 180. Of course, 180 times 2 gives you 360. So when we say 2 pi, it means 2 times 180, which is what there? 360. So that's how we derive this formula. Okay. Now, at this point, we know that 1 circle is equal to what there? 2 pi rad per second. 50 circle, it becomes x. All you have to do here is cross multiply. X times 1 gives you x is equal to 2 pi times 50 gives you 2 pi times 50, and that's equal to 100 pi, right? And then the unit becomes the unit of this part here, which is rad per second. So the correct answer here is 100 pi rad per second, and that is option A. Next question, question number 26. 26 says, which of the following is not part of the electromagnetic spectrum? That is question number 26. All right. A, alpha particle. B, gamma ray. C, infrared ray. D, radio waves. So which of this is not part of the electromagnetic spectrum? Now, here's what you want to note. Note that the electromagnetic spectrum is a whole range of electromagnetic waves, which includes gamma rays. So gamma rays is there. Number two, UV light. Okay, or number two is visible light. All right. Then you also have number three, microwaves. You have number four, radio waves. You have number five, X-rays. You also have infrared. You also have UV rays. So with all of this mentioned here, you want to also note that alpha particle is not part of it. All right. Gamma rays has been mentioned, is there. Infrared rays there. Radio wave is there, but alpha particle is not there. So alpha particle is not part of the electromagnetic spectrum. All right. Okay. Question number 27. It says a cell of internal resistance 2 pi supplies current to a 6 pi resistor. The efficiency of the cell is A, 12.0%, B, 25.0%, C, 33.3%, D, 75.0. I guess there should be a percent here. Okay, so how do we solve this question here? For 27, you want to note that the internal resistance determine the maximum current that can be supplied to a particular cell. All right. And for this, the formula we use for this 27, the formula 27 is that the efficiency, this is equal to small r all over capital R times 100%. All right. And from this, the value of small r is simply the internal resistance, the value of the internal resistance. All right. That's the value of small r. While the capital R is the other resistor here, which is this one. So this internal resistance is your 2 pi. So it becomes your small r. This is equal, efficiency is equal to 2 pi all over the external resistance, which is 6 pi, as we have, times 100%. Working on this is equal to pi cancels pi, 2 here, 1, 2 here, 3. So I'm having 1 over 3 times 100. So 1 times 100% gives you 1 times 100 gives you 100 all over 3%. 100 over 3 gives you 33.33333%. So my answer here is 33.3%. Let's see which option is that. That's option C, 33.3%. Okay. Question 28. 28 says the distance between the image and the object in a plane mirror is 40 cm. If the distance of the object is reduced by 9.2 centimeters, what is the distance of the object from the mirror? That becomes the question. So how do we solve this particular question? What do we do? The first thing we want to notice here is that they give you something called a plane mirror. And let's analyze a plane mirror a bit. This is question number 28. 28 here. Let's analyze a plane mirror. So let's say I have a ground level this way. All right. Let's say I have a ground level this way. And I have a plane mirror this way. So I'll call this plane mirror. Plane mirror. If a person comes here and stands this way, right? A person, let's call this a person here. Person. If a person stands in front of a mirror from this point to this point here, let's call this distance A. The person's image, let's call it this here, the person's image. Oops, the image is bigger than the person. Haha. All right, let's reduce this. Let's try to get the same height at least. Okay, something here. See, the person now has a bigger head. Oh my God. All right, please just manage my diagram, okay? Okay, so I have this. Here's what to note about a plane mirror. When a person stands in front, this is the back of the mirror, and this is the image. When a person stands in front of a plane mirror, the distance between the person and the mirror, as you can see, A, would be the exact same distance between the mirror and the image. So hence, for one of the most unique thing about a plane mirror is that the first thing you want to notice is that this distance between the object, which is the person here, from here to the mirror, which we called A, is the same thing as from the mirror to the person's image. Of course, the image is formed behind the mirror. That's the first thing you want to note. The second thing you want to note is that a plane mirror gives you the exact same size or the exact size of the image. That means the image would look exactly like the object or the person. There is no increase, there's no decrease, there's no magnification, and there's no diminishing. Just the same. Now, coming back to the question here, they said the distance between, note that they said image and object. Distance between the image and object in a plane mirror is 40 cm. So from the image, where is the image? The image is the person. So from the person here to the object. All right, so where's the image? Here's my image here. Where's the object? The object is the person. That means from here to here, right? It's about 40 cm. 40 cm. If it is 40 cm, that means distance from this point to the middle point here, 20 cm. That means the person is 20 cm from the mirror, while the person's image is 20 cm from the mirror. All right, so we've gotten this part here. All right, 40 cm between the object and the image, so 20 cm both of them from the mirror. They now said if the distance of the object is reduced by 9.2 centimeters. The question is this: if I want to reduce the distance of the object, does the object move closer to the mirror or away from the mirror? Obviously, if this man goes away from the mirror there, the distance will increase from 20 to perhaps 25, so an extra 5 centimeters. So that will be increasing. But if I want to reduce the distance, all I have to do is simple. I'll move the man towards the mirror. That's the concept. Now let me show you this real quick. If this man moves towards the mirror here, let's say to this point here, like this, you want to observe that from here to here, that's this point here, will be less than 20. You want to know that if I want to reduce the distance of the object, I have to bring the object closer to the mirror. That's the concept there. Now, they said if the distance of the object is reduced by 9.2 centimeters, that means this object or this person came closer to the mirror by 9.2 centimeters. So 9.2 centimeters. Now, if this is the case, the question will now be, what will now be the distance? What's the new distance of the person or the object to the mirror? What is this new distance here? We know very well that the distance, let's call this point A and let's call this point B. From A to B is about 20 cm. But this man moved towards B, that's the mirror, by 9.2 cm. So what is the distance left? Let's call it x. To get the distance left, it means 9.2 plus x is equal to what there? 20 cm. So let's find that 9.2 plus x is equal to 20 cm. X becomes 20 minus 9.2. So x is equal to 20 minus 9.2. And if I do that, my answer here is 10.8 cm. That means the object now has a distance of 10.8 centimeters. So 10.8. And it makes sense because we said the distance was reduced. So it now has to be a lesser value, which in this case is 10.8. What's the question there? The question says we should find what is the distance of the object from the mirror. So the answers to this question should be a 10.8 centimeters. This is the correct answer. Unfortunately, the correct answer is not here. So note that the answer is equal to 10.8 and actually in centimeters, not meters. Right? It's in centimeters, not meters. The option here is still wrong. Meters, 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 which even shows further that this is wrong. And if you're good with optics, this is actually under optics. If you're good with optics, you note that for optics, the units are usually in centimeters, not meters. So the actual or the correct answer there is 10.8 centimeters. All right. Just follow my solving here. That's how it's done. All right. Next up, question number 29. 29 says the phenomenon of radioactivity was first discovered by A. Marie Curie, B. J.J. Thomson, C. Henry Becquerel, D. Enrico Fermi. The correct answer here is Henry Becquerel. Right, so take note that Henry Becquerel discovered the concept of or the phenomenon of radioactivity. All right. Question number 30. 30 says, in the figure above, that's this one below actually, V is the viscosity and U is the upthrust. Which of the following equations holds when the falling body P has attained a terminal velocity? All right. When the body attains terminal velocity, which of this equation holds? Now, to solve this question, it's very simple. We'll bring in the equation for equilibrium. For equilibrium, we know that sum of forces going upwards is equal to sum of forces coming downward. That's all. The forces going upwards are U and V. So sum of forces going upward, V plus U or U plus V. Let's take V plus U is equal to sum of forces coming downward. Coming downward is just mg. So it becomes is equal to mg. So I have this. This is what is needed for equilibrium or for the object to attain terminal velocity. And if I move mg to the left hand side, I'll have V plus U plus mg becomes minus mg, and that'll be equal to nothing here, so it becomes 0. So let's see which option that is. That's option B. V plus U minus mg is equal to 0. That's your correct answer. All right. So this is where we'll stop for this particular question. So you have question 31 here. This is for you. So you solve question 31, leave your answer in the comment section. 31 says, which of the following is a semiconductor? A. Copper, B. Silicon, C. Plastic, D. Iron. All right. So you have these options here. Leave your answer in the comment section, either A, B, C, or D, and I will tell you if you're correct. Okay. Okay, guys, so please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.jonahemmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. All right. For the comment, I gave you a task, question number 11. solve it, leave your answer in the comment section, and I'll tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.